Today I'm going to illustrate how to compute the present value, also known as issue price, of bonds. I'll illustrate the working of this with problem 10-1b in your textbook, part 3. After reading through the requirements of problem 10-1b, I'm going to go ahead and set up my problem. If you've already attempted the problem, I'll now start to work through the solution. First, let's remember that a bond is made up of two separate streams of cash flow. The first being the par value of the bond, which is paid once over the life of the bond, and the second stream of cash flow being the interest payments, which are paid semi-annually over the life of the bond. We need to separate out those two streams of cash payment since they both occur at different times in the life of the bond. In order to calculate the present value of the par value of the bond, we'll use table B.1 in your appendix, which lists the factors for the present value of one future amount. Again, since that par value is only paid once. In order to calculate the present value of the future interest payments, we'll be using table B.3 in your table, which is used to calculate the present value of multiple payments in the future. Let's go ahead and identify the amounts for the par value and the interest payments. The par value is given in the problem to be $35,000. The interest payment we're going to need to calculate. We'll calculate that by using our PIT formula, our PIT formula, which is par value times the interest times the time, meaning how many times a year we pay out interest. The par value is $35,000. The interest, for this interest rate, we always use the contract interest rate, the amount that we're obligated to pay based on our contractual agreement with the bondholder. The problem provides this information to you to be 4%. This is the annual rate. Since we pay the interest payments twice a year, to figure out the semi-annual rate, you'll go ahead and divide by 2 or multiply by 1/2. That should give you a total of $700. $700 is therefore the amount of the semi-annual interest payment. So we've identified our amounts for the par value and the interest payment. Now we'll go ahead and look up the present value factors for those amounts given the tables we've already referenced. What you'll have to know when using the tables, use the tables that are found in Appendix B of your textbook to determine the present value factors. You'll see from these tables that you need to know the rate that is shown at the top. In order to calculate the rate, you'll take the market interest rate, not the contract, but the market interest rate, and you'll express it semi-annually by dividing by 2. You'll also need to know the number of periods. In order to calculate the number of periods, you will take the life of the bond, meaning the number of years that the bond will be paid interest for, and you'll multiply that by 2 so we can again express it semi-annually, so that both our rate and our periods are expressed on the same level. Let's go ahead and make sure we can find these factors on the table. So if you haven't already, go ahead and turn to Appendix B of your textbook. We will start with table B.1 to help us calculate the present value factor for the par value of the bond. Again, you'll need to know two things before you can find that factor. You'll need to know the rate, which was the market rate, expressed semi-annually, and you'll need to know the number of periods, which is the number of years times 2. Let's go back and find this information for our problem. We said to calculate the rate, we need to know the market rate and then express it semi-annually by dividing by 2. In this problem, we're given the market rate is 6%. 6% divided by 2 gives us a semi-annual interest rate of 3%. To find out the number of periods, we need to know the life of the bond, multiply that by 2 to express it semi-annually. We're told that the life of this bond is 4 years, multiply it by 2, that's a total of 8 periods. So we're going to be looking for the present value factor of 3% and 8 periods on our table B.1. Using the number of periods of 8 and the interest rate of 3%, we get a table factor of 0.7894. We then bring that factor over to our template and multiply it by the par value amount to find the present value of a future payment of $35,000 given today's market interest rate. That present value is $27,629. We'll now go ahead and find the present value factor for the interest payment using table B.3 in your appendix. Again, we have to use a different table to find out the present value for the interest payment, since the interest payment occurs at more than one interval over the life of the bond. Therefore, we use the present value of an annuity of 1, meaning a series of repeating payments. We use the same interest rate and number of periods as we did for the last table, which was 8 periods at 3%, giving you a table factor of 7.0197. We then bring that present value factor over to our worksheet, 7.0197, multiply it by the semi-annual interest payment, which we solved to be $700. Multiply the two to get the present value, or the amount, that bondholders would be willing to pay today for a series of semi-annual payments of $700 over the next 4 years. Add up both present value amounts from the par value and the interest payment to get the total present value of the bond, $32,543. Again, that's the amount that bondholders are willing to pay today for a bond that will pay them $35,000 at the end of the 4-year period, along with semi-annual interest payments of $700. Before we even started this problem, we were expecting this bond to sell at a discount, meaning below the par value being $35,000 and the cash issue price to be $32,000. We were expecting this since the market price of 6% is above our contract interest rate of 4%. Whenever the market rate is greater than the interest rate on our bond, investors will be willing to pay less because they could take their money elsewhere and get a higher rate. So we'd have to discount our bond. And that's what we see happening here. In Part B, you're asked to record the journal entry for the issuance. We know that we received cash on date of the issuance, and it's equal to the amount that we solved for, $32,543, which we previously solved for. We also know that we've made a promise to pay the investor $35,000 or the par value at the end of the 4-year life. So that is our obligation and therefore credited as that liability amount. The difference between the two, the par value and the cash proceeds received, will be debited to the discount on bonds payable, since investors did not pay us enough cash as was equal to the par value of our bond. So that is your journal entry to record the issuance of bonds at a discount. And that has been how to solve for the issue price of a bond using the present value tables, and also to record the journal entry.